Hey folks, welcome to my channel Number Pen. Today we have two interesting problems. So you have the problem on your screen. Find the left and right hand limits of f of x equals x square minus 4 divided by x plus 3 into x square plus 4x plus 4 at x equals minus 2. And we know that when we've been asked to calculate the left hand and the right hand limits, we'll have to figure out the limit at a particular point x equals minus 2 in this case. So the left hand limit would mean a value which is greater than minus 2, which means it is minus 2 minus h. And the right hand limit is a value which is lesser than minus 2, which is minus 2 plus h. And in both the cases, h being infinitesimally small, infinitesimal, and h tending to 0, right? So we've been asked to find both the limits. So we'll figure out first if the expression is you know, can further be simplified. So it looks like it can. So let me write down the equation separately. So x square minus 4 is nothing but x square minus 2 square, right? So this can further be written as x minus 2 into x plus 2. And you have x plus 3 in the denominator, which we will write it as it is. And what is x square plus 4x plus 4? It's nothing but x plus 2 the whole square, right? Because you have a plus b the whole square equals a square plus b square plus 2ab. And in this case, you've got a equals x and b equals 2, which means x plus 2 the whole square equals x square plus 4x plus 4. So I'm going to rewrite this as x plus 2 the whole square, which is nothing but your x plus 2 into x plus 2, right? So now we are left with an x plus 2 in the numerator and an x plus 2 in the denominator, which we can comfortably cancel out. So I'm going to do that, remove one x plus 2, and then we are left with x minus 2 divided by x plus 3 into x plus 2. So let me write this expression out. So this is the final expression. I don't think we can simplify this further. Let's write it out and then go ahead to calculate our left hand limit and right hand limit, right? So let me do LHL first, which is my left hand limit. I'm going to move this problem, which we will do next, to the next screen, next page. My apologies. So what is LHL in this case? LHL is at x equals minus 2 minus h, right? And h tending to 0. So let's replace x in the equation above and let's see what do we get. Let me write it like this because I'm going to replace x by minus 2 minus h. It's tending to 0. And when I write my numerator, it is minus 2 minus h minus 2. So it becomes minus 4 minus h. And that is going to get divided by my denominator, which is x plus 3 into x plus 2, where I'm going to replace my x with minus 2 minus h. And when I do that, I get the first part of my denominator becomes minus h because minus 2 plus 3 becomes plus 1. And so it becomes minus h plus 1. The other part of the denominator, which is minus 2 minus h plus 2, remains as minus h, right? And so now when I do a substitution of h equals 0, right, as h tending to 0, what I get in the numerator is a minus 4, right? And what I get in the denominator, the first part is 1 minus h, so it remains as 1. And the second part, which is a minus of h, right? So which becomes a minus 0. And what happens to the negative sign in the numerator and the denominator? It gets cancelled. So we have so we have that's a positive infinity, right? So let me write this out. So that's a positive infinity. So now that we've calculated LHL, let's move to RHL, right? Which is my right hand limit where x takes a value which is greater than minus 2, right? And what is that? It's h, right? And when I'm going to substitute x with minus 2 plus h, what I get is an expression which is very similar to what we saw in our LHL, but which is small with a small difference, right? So your x minus 2 in the numerator becomes minus 4 plus h, and my x plus 3 part of the denominator becomes minus 2 plus 3 plus h, which is nothing but my 1 plus h, right? And then I have my x plus 2 becoming minus 2 plus h plus 2, which is nothing but a plus h, right? And when I do a h tending to 0, I have my minus 4 plus h becoming minus 4. My 1 plus h becomes 1. And then I have 0. Now we have a negative sign with us, but it takes again number which is negative of infinity, right? Now we know that limits will have to be finite, right? So when LHL not equals RHL, because in this particular case LHL is a positive infinity and RHL is negative infinity, I would say that LHL and RHL are positive infinity and negative infinity respectively, but the limit does not exist, right? So that's the way to put across the final answer for this particular question. So we'll move to a very similar problem, and I thought we'll do one more problem of similar type. Uh, Now, this is a problem where we've not been explicitly asked to find the LHL and the RHL, but instead we've been asked to find the limit of this particular expression, right? So I'm going to write this expression before I read it out. I'm going to write this out separately. Folks, I'm finding a problem here whenever I uh, write it in the equation format. It always places it in the center, and I'll have to explicitly do a left justification. So if you folks know of any technique that can permanently keep it left justified, right? I'm referring to the equation, not to the regular text. Please do, post your comments as to how I get it done. That'll help me a lot. Otherwise, every time I play, it gets placed in the center, and I then do a left justification of that. So kindly help me out here. So I'm going to copy this, coming back to the problem. So again, something very similar to what we saw in the previous problem. And I'm going to copy it out here. X square minus 9 is nothing but x square minus 3 square, right? So I can write this as x minus 3 into x plus 3 comfortably. And then I'm going to have x square as one part of the denominator. And I'm going to, what is x square minus 6x plus 9, right? So I can do this in two ways. Uh, I mean, either uh, you can recall the formula a minus b the whole square equals a square plus b square minus 2ab. So if my b is 3, my x minus 3 the whole square is nothing but x square minus 6x plus 9, right? Or the other way, you just factorize it, and 6x in the denominator, which is x square minus 6x plus 9, can be rewritten as, let me do it that way for some of the other folks who might want to look at it in that fashion. So I'm going to put it across in that manner rather than directly applying formula. So I can write 6x as 3x minus 3x, right? And when I can pull out, I copy the numerator as it is. I copy the x square part of the denominator as it is. And when I'm going to write this out, I'm going to do it here. I can rewrite this as x into x minus 3, right? And I'm pulling out 3 again, and I'm going to make this as x minus 3, right? I hope you got what I have actually done. The first part of the expression, which is x square minus 3x, I've just pulled out x. And the second part of the expression, which is minus 3x plus 9, I have pulled out minus 3, right? So when you rewrite this, what you actually get is what we discussed earlier, x minus 3, the whole square, right? So I'm going to rewrite that as x minus 3 into x minus 3. So now we have an x minus 3 in the numerator, and we've got an x minus 3 in the denominator as well. That allows us to cancel one of them. And I'm going to move to the next line, and copy this particular simplified expression, right? Extending to 3, and we've got x plus 3 divided by square into x minus 3. As extending to 3, you notice that your numerator takes a finite value and your denominator is taking 0, right? That makes us believe that the limit is infinite, and therefore it is a limitless expression, and therefore no limits exist, right? So when we come across these expressions, just do a quick check. Now we know that uh, when extending to 3, we have a left hand limit and a right hand limit, right? So I'm going to do this quickly here. So let's evaluate LHL. And what is LHL? I'm going to write it in the next line. my LHL equals x tending to 3 plus h, right? Sorry, 3 minus h, right? Where h is tending to 0. So when I do that and when I write this expression, what do I get? So my x replaced here becomes 6 minus h, and my x replaced here becomes 3 minus h the whole square, and my x replaced here becomes 3 minus h minus 3, which becomes minus h, right? Now I'm going to replace this. This is no longer in the form of x, it's in the form of h, where h tending to 0. So when I write this, my numerator, when I do a substitution of h equals 0, my numerator takes the value 6, and my denominator, one part of the denominator takes the value 9, which is because it is 3 minus h the whole square, which is 3 minus 0 the whole square. And the other part is going to take minus h, which is, I retain the minus sign, and so minus sign remains, which means I'm going to call this left hand limit as negative of infinity, right? And let's do the RHL, which is the right hand limit where x takes a value which is slightly greater than 3. And there is 3 plus h, and we have the RHL here. And I'm going to write this equation again, and I would. So this is what we have our RHL as x tending to 3 plus h. Our numerator becomes 3 plus h plus 3, which is your x plus 3 becomes 6 plus h. Your x square part of the denominator, which is 3 minus h, 3 plus h the whole square, and your x minus 3 part of the denominator becomes 3 plus h minus 3, which is h, right? So I don't think we can simplify this any further. So therefore, when h equals 0, we are left with 6 by 9, but this time we don't have a negative 0, right? 6 by 9 into 0, right? So what is that? That's a positive infinity, right? So this is a question where we've been asked to find the limits, and in this particular case you find that LHL not equal to RHL because your RHL is positive infinity and your LHL is negative infinity, right? Therefore the expression is limitless and the limit does not exist, right? So that would be our answer for this particular question. Thank you, folks. I hope you found the content useful. Please do subscribe to my channel and support. Thank you.